Next, we'll talk about the factor theorem. What that says is if I were to give you a binomial, and we're going to determine whether that binomial is a factor of some polynomial expression that you're given. In order to determine if it is a factor, we're going to use synthetic division and then hope that our remainder is 0. So looking at this example right here, we're doing synthetic division, we get a remainder of 0. That means that whatever the binomial was, that was in fact a factor of the polynomial. So we're going to use synthetic division. If we get a remainder of 0, then we've got a factor of our polynomial. So let's look at our first example. We need to show that x plus 5, that's our binomial, is a factor of x cubed plus 2x squared minus 13x plus 10. We've got that whole long polynomial. Then we're going to figure out the rest of our factors and put all of that together. So when we are doing synthetic division here, if you're given a binomial and it's got that x somewhere in your expression, to start synthetic division, we need to change the sign. So it starts off as x plus 5. I'm going to change that to a negative 5. Then I'm going to put my half box and put all of the coefficients of each term here. Let's see, are we missing anything? Do we need any placeholders? 3, 2, 1, 0. No, we're good. So all of my coefficients here, 1, 2, negative 13, and 10. Remember, if I'm missing any of my terms, like say this x squared was not here, I have to put a placeholder there. But in this case, we've got the 2. So when I'm doing my synthetic division, I'm going to start by bringing down the 1. Here's my 1. Multiply negative 5 times 1, we got negative 5. Add 2 and negative 5, we've got negative 3. Multiply negative 5 and negative 3, 15. Add those together is positive 2. Negative 5 times 2 is negative 10. Add those together, we do in fact get a remainder of 0, which is exactly what we want. So that tells me x plus 5 is a factor of this entire polynomial. Now what I've got left over, that's going to help me make up my next polynomial. So with my remainder of 0, I'm good on that. The next term to the left of that, that's going to be my constant term. The negative 3 here is my linear term, so there's going to be an x with that. The 1 at the very front, that's my quadratic term, so I'm going to have an x squared here. If I had another term in front of that, I would put an x cubed with it. In front of that would be an x to the 4th. So starting at this very last number, right before our remainder, that's just going to be whatever that number is. Then go to the left, that one gets an x, then an x squared, and so on and so forth. So I'm going to rewrite this as a polynomial. My coefficient is 1, so 1x squared is just x squared, minus 3x plus 2. And again, I had a remainder of 0, so I don't need to include that. Now I'm going to factor this trinomial and figure out the rest of my factors, because I already know about x plus 5. I need to see what else I've got. So in a trinomial, there's just a 1 in front of my x squared, so I can do my multiply-add method. I want to multiply to that last number of 2, add up to my middle number of 3. So thinking about your factors of 2 that add up to negative 3, you could either do 1 and 2 or negative 1 and negative 2. In this case, we're going to use the second pair. So my factors are x minus 1, x minus 2, and I'm going to go ahead and include the original factor that I found at the very beginning, x plus 5. Now it doesn't matter which order you put these answers in, as long as you've got the correct ones with the appropriate signs. Let's look at another one. In this next one, we have x plus 4 and x plus 3. We're trying to prove that both of those are factors of this whole long polynomial. Then we're going to factor the rest of it. So when you've got two different binomials, we're going to divide twice. We're going to do synthetic division 2 times. It doesn't matter which order you do it in. It does not matter which one you start with. Let's say you want to start with the x plus 4. Remember, it's got an x with it, so we need to change our sign to a negative 4. Put our half box. And then let's see if we're missing any terms in our polynomial. 4, 3, 2, 1, we're good. So all of my coefficients are 1, 9, 23, 3, and negative 36. I'm going to start by bringing down my 1, multiply, add, multiply, add, multiply, add, multiply, add. So far, so good. We got a remainder of 0. So we know x plus 4 is going to work. So now let's try the x plus 3. I'm going to take this second factor and only apply it to the leftover coefficients from after my first synthetic division. So I'm going to do another half box off of this. Now I'm going to put my -3, so remember switch that sign, I'm going to put that -3 on the outside and only use these coefficients that are left over. We don't need to use the remainder. Bring down our 1, multiply, add, multiply, add, multiply, add. We got another remainder of 0, which is perfect. And now, based on the last final coefficients, we've got a remainder, our constant, linear, quadratic. So I'm going to rewrite this as x squared, because the coefficient is 1x squared, plus 2x minus 3. So let's factor that. Multiplies to -3, adds up to 2. That could be 1 and -3, or -1 and +3. And that's going to be our group there. So my final answer, so hold on, sorry. Okay, my final answer, I'm going to use these two factors, x minus 1, x plus 3. I had another x plus 3, so we can just write x plus 3 squared because there are 2 of them, and x plus 4. You can also write it as x minus 1, x plus 3, another x plus 3, and x plus 4. Either one of those is perfectly fine. And there's our final answer.